What's up, Faisal? Steady, easy. Yes.
If I do this and then shift solve, it should give me the answer of x, shouldn't it?
I can see x is 0.
X equals 0?
That's my pink. So I don't understand your question.
So this is right?
But
X equals 0?
Yeah, but I haven't used this function before, so I don't know. I don't know what L minus or means. I forget. Someone told me before. Do you know?
I never cared about the L minus R, but that's how we used to do it. Okay, use a...
That's something which is not 0.
Yeah.
Linear?
Okay.
Or no, you want something difficult, don't you?
No, anything, just to see
If it works.
Yeah.
Well, this should be a
Equals
quarter.
to, yeah, make it equals to... Or...
3.
Okay, yeah.
So x should be 1.
Yeah. And then, no.
Oh, shift.
So,
So.
equal... X equals 1.
Yeah, but I suspect that this only works to give you one answer. So here, it will fail to give me 2 answers, possibly. Maybe it knows for quadratic.
But this is one answer. Oh, no, it's not. Plus and minus, yeah.
See, they only gave me one answer.
Okay.
Yeah. Okay.
But for the... Is it one answer? For the root x?
It is. The one you showed me, it is. Okay. Let's continue. Yeah. What we're going to look at now is practical problems. Are we listening? Listening, yeah? Listening. So, for these problems, we have a story, and we're trying to make something maximum or minimum in the story. So, I'll give an example. Listen carefully. Here's an example. We have a farmer, and he has a garden beside... Are you listening? Sorry, please. The farmer has a garden. We're looking from the sky, and in the garden he has, let's say, roses, and he wants to build a fence, and the fence needs to go around the garden like this, and he's trying to make the fence cover as much as possible. So a bad shape would be this. If he made the fence like this, this is quite bad because it doesn't cover so much. Likewise, a shape like this is quite bad. It doesn't cover much. We want to find a shape that covers the most. So, the question is, by using 100 meters of fence, how can he cover the most of his garden? So he wants to make a fence that goes around his garden, and he only needs to make 3 sides because he already has a wall. Okay. So, before I continue, do you understand the problem he faces? He's trying to make a fence as big as possible around his garden. Okay. And he only has 100 meters of fence. So, let's call this side here X. How big would this side be? X. And so, how big would this side be?
100
minus 2x. Because it's 100 in total.
Perfect.
What is he trying to find here? He's trying to find the area, which is x times 100 minus 2x. And what does he want to do here? He wants to know what is the maximum he can make this. So the area is 100x minus 2x squared. How do we find maximums?
Draw a graph.
Yeah, derivative. Using a graph, true. Derivative. What about the derivative?
Second derivative.
Yeah, but before the second derivative, what do we do with the first derivative?
Make it the stationary point.
Yeah, and how do we find the stationary point?
25.
Make the derivative
0.
equal to 0. Let's confirm it's a maximum. What's the second derivative here?
Minus 4.
Minus 4. Negative makes concave or convex? Concave, which makes it a maximum, so that's good. What's the x here?
25.
25. The area would be 625 when you take this and put it back in here. The shape, isn't it?
1,200.
Oh, sorry. No, yeah. It's 25 times 50.
1,200.
1250, is it? Meters squared. Meters, this is the area. So the best shape he should use is one which is 50 here. No, sorry, 25 here, 25 here,
50.
and then 100 minus 50, 50. This is the best shape for him to use. It gives him the most area. Any other shape will give him less area. So this is the best way to use his fence, to make a 25, a 50, and a 25 shape. Maximum area. Okay? So this is kind of a simple question. They can get very complicated. I'll do a complicated one next. But the basic idea is this. To minimize or maximize, you basically do what we've been doing so far, which is to solve this and then check this. Is positive if you want a minimum and negative if you want a maximum. This is the key idea, but we've been doing this already. We're just applying it to a problem. Okay, write this one down, please. I just made this one up, but it might be like one of the questions in the worksheet, but I just made it up.
Is the practical problem in our first semester exam or the finals?
First, in section B. Continue? Yep. No. Who are we waiting for? Okay, we're waiting for 4 people. Although I don't trust you 2 down the back. I have a feeling you were probably on your phone instead of writing.
My phone isn't even on the table.
In your pocket?
Yes.
Catching Pokemon under the table? You're not a Pokemon Go person. You're more, let's see, Candy Crush Saga. Yeah. That's, or maybe something like Farmville or something like this. No, am I way off?
Happy Aquarium.
What's the app?
Nothing.
To the- Oh, come on, you're waiting for the bus and you're bored and you want to play a game and you open...
I don't have any games on my phone.
Oh, you're like that. Oh, right.
Just like that.
Social media?
Yeah.
Yeah, okay. Posting fake tweets, is it?
No, not Twitter anymore.
No Twitter anymore. Donald Trump ruined it for you, yeah? Yeah. Twitter was so good until he joined. Alright. Do you have that now? Yep. Okay. Now, time to do a difficult one, so you'll have to listen very carefully. Can I scroll down now? Yep. Okay. Oh my goodness, Wong! Listen carefully, please.
Do we have any 3D objects in this?
Yes, that's one of them, but this is not what I'm going to do next. Economics students, have you done supply and demand? As you if you increase the price, what happens to demand? Goes down, usually. And likewise, if you decrease the price, what happens to demand? Goes up, yeah. Now, the question I'm about to give you was on the exam for everybody, business, science and engineering students, but the business students I think will appreciate it more since it's an economics problem. Okay? So the problem is this. You have a coffee shop. That's what I said, coffee shop. And in this coffee shop, when the price of coffee is €2, then we'll have 100 customers, so 100 sales. And then you discover when you decrease the price, what should happen? This is common knowledge. Increase the sales. You sell 150 coffees. Oh, and by the way, all these numbers are per day. Okay, so far this makes sense, right? Now, as you run a coffee shop, you have two types of costs. The first cost is a fixed cost. So what this means is you must pay it every day, whether you open the shop or not. It's a cost you can't avoid. An example of this cost might be what? Rent. Whether you open the shop or not, you must pay rent, or tax, or whatever. So we'll say for this shop, the fixed cost is €70 a day. Maybe this is the rent. So it doesn't matter if you're on holidays and the shop is closed, you still must pay €70, fixed cost. But then you have something else called a variable cost. This is the cost per sale. Every time you make a coffee, you must pay for the coffee cup, the beans, the milk, etc. If you have lots of sales, that's good, but you also must buy more coffee, cups, beans, milk, etc. So we'll say per cup, it's 33 cents. This is the cost per cup. Okay, so before I continue, are we happy with the information here? Yeah? So let's imagine the coffee shop opens and sells 1 cup of coffee on one day. What is their cost for that day? 70 euros and 33 cents is their cost. Pretty big. And how much money did they make when it was €2 a cup? They made €2. That's a problem. They lost a good bit of money. So they probably want to sell more than 1 cup. Probably, yeah. So the coffee shop needs to figure out what's the best price. If the price is too high, then they will not have many customers and they will lose money. But what would happen if the price was too low? For example, if the coffee was sold for 32 cents.
They'll be losing.
Each sale they would lose a cent, plus the 70 euros for opening the shop and paying the rent. So there must be some number in the middle which gives them the most money, the maximum money. You understand? Yeah. Okay, so let's start this now. So the first question is, just a little bit of notation. I'll use the letter P for price and Q for sales. So, when P is 2, Q is, what did I say? 100. And when P is 1.5, Q is... Oh, sorry. When P is 1, Q is 150.
We can draw a linear.
Yeah, we can draw a linear graph, but we don't do it like what you did in economics. For me, I'll put the P here and the Q here. This type of graph in economics is called inverse demand. I don't know if you've done it with Donald, but anyways, I'll put P here and Q here. So when P is 1, Q is 150. And when P is 2, Q is 100. So as I increase the price, the sales decreases. Let's find the formula for this relationship. We can use M. Y equals mx plus c. In this case, it'd be Q equals M P plus c.
Yep.
How can I get the M?
You get
y2 minus y1 over x2 minus x1.
M is minus 50.
150 minus 100 over 1 minus 2. So M is minus 50. So I have Q equals minus 50p plus C. How can I get the C? Use a point. Let's just use this point here. 150 equals minus 50 plus C. So C is 200. So I have my formula. Q equals minus 50p plus 200. How many copies do I sell if the price is 0? If I give the copies away for free,
200.
200. How many copies do I sell if the price is 4 euros? 0. Too expensive. Okay? So, both 0 and 4 euros are bad prices. 0, you make no money. 4 euros, you have no customers. Okay. Why did this lock? Is my battery critical? Okay, next, let's find a formula for the total cost. Okay, so we'll need to use this later. Total cost. What are the two costs for this business?
70.
The fixed cost and the variable cost, which is 70 plus...
Q.
Yes?
0.33
Q, because for each sale it's 33 cents. Let's replace the Q with P. So the total cost is 70 plus 0.33 times minus 50p plus 200. Total cost is 70 minus 0 point something. 0.33 times 50.
15.5.
Thank you. Exactly. Plus 66. So we get total cost is,
Minus 16.5p. Plus.
yeah, minus 16.5p.
Plus
70 plus 66.
136.
136, yeah? Is that okay? Yeah. So if the price is 0, what's the cost for the business? It will cost them 136 euros to do business at price 0. As we increase the price, we get different costs. Yeah. So, let's go on to the next part. What is the total sales? Total sales. Well, if they sell Q at price P, how much money did they get in? The total revenue, the total sales. Q multiplied by P.
Isn't it 70 minus QE?
For what?
For the profit.
No, we're not at profit. We're just money coming in the door, sales. What is the formula for Q? Minus 50p plus 200 times P,
Yeah.
which is minus 50p squared plus 200p. If they sell the coffee for 0, how much money do they get in?
0.
No surprise, 0. If they sell it for 4 euros, how much money do they get in? This will be 0, because at 4 euros nobody buys it, and the sales is 0. Yeah? Okay. Next, what the business really cares about, the profit. How do we get profit? It's the money the business gets in, the sales, minus the cost. That will be minus 50p squared plus 200p minus, which is a plus, 16.5p minus 136. So that will be minus 50p squared plus 216.5p minus 136. This is the profit. The business doesn't care how many cups it sells, how much money comes in, how much money goes out. The only thing they care about is their profit, how much money they have at the end of the day after the sales and the costs. They only care about profit, nothing else. Do they want to make the profit maximum or minimum? Maximum. How do we do that? Derivative equals 0. Let's check it's a maximum. What's the second derivative here? Minus 100, which is negative, which is a maximum. Okay, when I solve this, what do I get for P? 2.165. So the best price is 2 euros and about 17 cents. Although, since most places round to 5 cents, probably they should pick something like maybe 2.20. But we'll just keep it at 2.17. Now, I just want to show you that on a graph here. We'll do the graph here. So tell me this, imagine the coffee shop was selling coffee for, let's say, €2.50, and you recommend they decrease the price from €2.50 to €2.17. What will happen to their profit? Increase or decrease? Increase. Because they were charging too much.
Depends on their cost.
No, well, in this story, they would make more money by lowering the price. Lowering the price would get more customers. Yes, yeah. Now, let me just show you this with the table, just so you can see it for real. Here, I'll put the price. So let's say the price is 0. Here, I'll put the fixed cost. It's always 70. Here I'll put the variable cost. It's 0.33 times Q, which I'll put in the next box. These are the numbers sold. I gave you a formula for that. What was it? Minus 50 times the price. Yeah, I need to put in minus. Okay. What else will the business need? It's sales, which is P times Q. Price times how many sold. So sales are 0. And then finally the profit, which is the sales. Oh, I left out something here. What should I have here? I should have a total cost, shouldn't I? Which is this one plus this one. Okay. Let me just move these in a bit. Okay. Right, and then the last one here is profit, which is sales minus total cost. So, let's increase the price by 1 cent. No, sorry, I'm stupid. Oh, and the profit, of course, these should all be to 2 decimal places because it's money. Okay, so when we charge 0, do they make a profit or a loss? They make a huge loss, 136 euros per day. When they increase it by 1 cent, what's the situation? It's still a loss, but not as much. Let's move this down to, let's go to 3 euros, which would be here. Okay. So let's move down here. As they increase the price, they make less of a loss. So keep going. Whoops. Still making a... No, I've gone too far. Yeah. No.
So it's all right.
Stop. I've typed in something wrong, haven't I? Oh, thank you. The rent is increasing every day by €1. Yeah, that would be a problem. Yeah, that explains what was going wrong here. Let me just fix that up. Hold on. But it bothers me. Right. Okay, so it makes a loss. And we increase the price, and then what happens here, the economics students can maybe tell me, here, look what happens when you increase the price to 77 cents. What happens? Instead of making a loss, it makes a profit. There's a name for that in economics and business. Break even. So they must charge at least 77 cents to break even. But that's not what we care about. We want to know what is the most profit they can make. So if you look, as they increase the price, they make more and more money. Increase the price, make more and more. Keep going. Alright. Increase the price, and then here.
Price drop. The profit drops.
Yeah, as soon as you hit 216, 217, we make maximum profit. But what happens if you try to increase the price past this? Now we start losing money. And then when will it get back to 0? We think we said at €4. not even at €4. We start making a loss again back at $3.57. We've charged too much. We don't have enough customers. We're making a loss now. Now, the reason I'm doing this question is this was a Section B question. The good news is all of it is a Section B question. So it's one big Section B question, and they break it up into parts. So they would say, what is the total revenue? What is the total cost? What is the total profit? What is the maximum profit? Therefore, what is the best price? The only difference is, in the exam question, it was a DVD shop. Still do it the same way, even if it's DVDs. Doesn't matter. Or Blu-rays. Yeah, or Blu-rays, yeah. Okay, now wait, before you go, the homework for this, you do need to do all the questions because they're difficult and it's important to do them all. So the homework is to do all the questions.
Do we get the question for business for?
No, it's a common exam. So one year it might be a business practical problem that everyone does, or another year it might be an engineering problem. You know, there's different stories.
What was the last year?
Last time they'll explain it. Yeah. Like they'll explain what they mean by fixed costs, and they explain it. They pretend you're an idiot, yeah. Well, maybe not an idiot, but Ian, the last one I can remember is the DVD example. No, that's not true. Engineering. You had to build a tank or something. Yeah.
I hope it's
Yeah.